Hello guys, so today I'll be solving this problem. So this is the problem. So number of smooth descent periods of a stock. Okay. So the problem states that you are given an integer array prices representing the daily price history of a stock. Okay, where price of I is the stock price of the ith day. Okay, then we have the definition of smooth descent period. So it states that a stock consists of one or more contiguous days such that the price on each day is lower than the price of the preceding day by exactly one. Okay, this is the definition of smooth descent period. So it basically means let's say I have p of I something. Okay, and after this ith position, if I am, so the next element, which is p of I plus 1, if this guy is equal to p of I minus 1. Okay, and subsequently let's say p of I plus 2 is equal to uh, p of I plus 1 minus 1. Okay, and like this if it goes. So this is a smooth descent period. Okay, so yeah, this is the definition. So finally we need to return the number of smooth descent periods. Okay, so yeah, this is the problem statement. Okay, so just the total number of smooth descent periods we can get. Okay, so it's a pretty easy problem. Okay, so only one concept we need to know is sliding window. Okay, so it's a typical sliding window problem. Okay, so yeah, so how we can apply a sliding window is, so let's say I have, let's say uh, p1, p2, p3, p4, p5. Okay, let's say p3 is p2 minus 1. Okay, and p4 is p3 minus 1, and let's say p5 is p4 minus 1. Okay, let's say the underlying values are something like this. So what we can do is, okay, and yeah, here also let's say p2 is p1 minus 1. Okay, so what we can do is, so I will start iterating from this guy. Okay, and from that I will keep on extending my windows. Okay, so as I'm keep on extending, I will just check the next element whether the my next element is lesser than my previous guy by only 1 unit. Okay, so in this case, yep, this guy is like lesser than, because I'm stating that p2 is p1 minus 1. Okay, like that I will again extend this window, so this will become p3. Okay, now p3 is p2 minus 1. Okay, so like that I will keep on extending, and finally I will reach the end. Okay, now once we have found a subarray, okay, where all the elements are satisfying my smooth descent period definition. Okay, then what I can do is, so I can apply this formula, which is n times n plus 1 by 2. Okay, which will give me the number of subarrays I can generate. I can generate from an array of length n. Okay, so yeah, that's the idea. Simply iterate over the array. Okay, and for every element, okay, keep on extending your window. Okay, and once you have found an array, okay, or let's say you have a stopping criteria where the next element is not lesser than 1 from the previous guy. Okay, then in that position simply calculate this amount. Okay, so once you calculate this, then you know in that subarray you can generate this many subarrays which will all follow your smooth descent period. Okay, and like that you will keep on moving and adding up to your answer. Okay, so I can run a test case here. Okay, so for example here, so we have been given 3, 2, 1 and 4. Okay, so yeah, I'll start with 3. Okay, then I will look into my next guy. Okay, now I'll check whether 2 is lesser than 3 by 1 unit. Yup, it is. Okay, So I will extend my window to this. Okay, then I will iterate over this guy. Okay, 1. Now I'll check whether 1 is lesser than my previous guy by 1 unit, which is 2. Yep, it is. Now I will again extend. Okay, now I'll point to this guy, okay, which is 4. Now I'll check whether 4 is 1 unit lesser than my previous guy here, which is 1 here. No, right? Because here it will be 4 minus 1, which is 3, right? So it's not 1. Okay, so we just need to do reverse of it, because yeah, I'll be subtracting my previous to my next guy, so this will be minus 3. But yeah, so the idea is it's not 1, right? So I'll stop here. Okay, and whatever length I have gotten for this window, okay, so here I will simply apply this formula. So here I have 3 elements, so this will be 3 times 3 plus 1 upon 2. Okay, so if I calculate this, this will be 3 times 4 upon 2. Okay, so this will get cancelled out and this will give me 6. Okay, this means this subarray will give me 6 subarrays which will all satisfy this condition. Okay, so we can have a look. So here I have 3 to 1, right? So 3 itself will satisfy, right? Now I have 3 2. Okay, in 3 2 it's satisfying, right? Then I have 3 2 1. Okay, this subarray is also satisfying my decent condition. Okay, also if I look here, I have 2 here, right? Okay, I can only choose 2. Okay, that's also a valid like smooth descent period, right? Then I can also choose 2 1. Okay, and finally I can have a single one. Okay, so all these subarrays are generated from this part only, and all of them are satisfying my smooth descent period. So yeah, I have 6 of them here. Okay, now finally my pointer will be pointing here. Okay, then I will try to extend window from here, but here I do not have any element, so I'll stick to only one element. Okay, so here also I will apply the formula. So this will be what, 1. Okay, because the subarray length is 1, I'll apply 1 times 1 plus 1 upon 2. So this will give me 1 times 2 upon 2, which is 1. Okay, so the total number of subarrays I can generate which will follow the smooth descent period is this 6 plus 1, which will give me 7. Okay, and I can see like the answer is 7. Okay, now let's do it for one more test case. Okay, which is this this guy, which is 8 6 7. Okay, so yeah, I'll start from here. Okay, then I will look into my next guy. Okay, so whether my next guy is less than by 1 unit. Nope, it is not. So the window will stay at here only. Okay, so I will simply apply this formula. So this will be 1 times 1 plus 1 upon 2. So this will give me 1. Okay, then from my next position I'll check whether I can extend my window. Okay, so from this guy I'll check to the next guy. Okay, so this is 7. Now I'll check whether 7 is 1 unit lesser than my 6. Nope, it is not. Okay, then that means the window length here is 1 only. So again I will do 1 times 1 plus 1 upon 2. Okay, so this will again give me 1. Okay, similarly for 7 also, if I look at the next guy, okay, so the next guy is not differing by 1 unit, it's exactly the same element, which means from this guy the window length will be 1 only. So this will be again 1 times 1 plus 1 upon 2, which will be 1. Okay, and the same thing goes for here also. Okay, because after this I do not have any element, so yeah, I will again do 1 times 1 plus 1 upon 2. This will give me 1. So finally I will add up all the results, and this will be what, 1 plus 1 plus 1 plus 1, this will give me 4. Okay, and as I can see the answer is 4. So yeah, that's the idea. Just simply iterate over all the elements. Now at every element position, try to extend the window. Okay, by satisfying the condition like the next element should be 1 unit lesser than my previous element. If you are able to do that, keep on extending. Okay, and wherever it fails or you reach the end, okay, after that simply apply this formula to calculate the number of subarrays, okay, inside that segment you can generate, because all the subarrays will satisfy your smooth descent period, okay, in that subarray. So yeah, that's the idea. I'll simply code it up So I'll start with Rust only, and then I can show you C++ and Golang implementation. Okay, so I'll start with Rust. Okay, so I will initialize my answer as 0, and I need to return i64, also I'll say as i64. Okay, then I will initialize prices length because I will be extending my window. Okay, then I will use a variable I. Okay, and I will initialize it to 0. Okay, then I will say while I is less than n. Okay, and finally I need to return answer, so yeah, I'll just write it up. Okay, then yeah, now I'm iterating over all the elements. Now for every element I will check how much I can extend the window. Okay, so I'll create a variable let mut len. Okay, okay, so I will be initializing to 1 because when I'm starting my window I already have an element which is the element itself, right? So yeah, my length will be 1, and from that I will be checking whether I can extend it or not. Okay, so I'll be saying I plus len. Okay, until my I plus len is less than n, and prices of I plus len minus 1. Okay, so this will give me my current ith element. Okay, now I'll check my next ith element, which is prices of I plus len. Okay, so I will do this a bit. Okay, and so yeah, prices of I plus len. Okay, if their difference is 1, okay, then I will keep on extending my window, which is len plus equal to 1. Okay, so I'll keep on extending this, and finally once I have stopped, okay, that means I have a segment, okay, where all the subarrays are satisfying my smooth descent period. Okay, so I'll simply update my answer to ans plus len times len plus 1 upon 2. Okay, and I don't need to do any modulus, so yeah, I'll simply update my answer to here. Now the thing is here, len will be initialized to i32, so what I can do is I'll just create another variable, let's call it len. I will say len as i64 because yeah, in Rust type checking is pretty serious, so yeah. And instead of using len here, I will be using this capital Len. Okay, cool. So yeah, and after this I'll simply return my answer. So let's run it for all test cases, and cool, we got an error, and the error is I'm using C++ in Rust. Cool. So it should be len. Okay, time limit exceeded. Oh, okay, because I'm not like incrementing my I. Okay, even after this. Okay, so what I will do is I will simply increment my I to len. Okay, because that much of element I have already covered. Okay, so I will simply update my I by adding the len that I have covered. Okay, now I will run it for all test cases. Cool, I'll submit, and voila, it passed. Cool, so that's the idea. Now if we look at the time complexity here, okay, so we have this while loop, okay, where I'm iterating over every element. Now inside that I again have a while loop, okay, but here the thing is this while loop is touching the next elements. Okay, so at max I'm touching so I'm touching every element exactly one time only. So that means my overall time complexity will be big O of number of elements, okay, or big O of prices length. Okay, cool. Now let's look at the space complexity. Now in space complexity you can see like I'm not creating any auxiliary space. Okay, all these are variables only, so it's constant, so it's a big O of 1. Cool, so that's the solution, and this is the time complexity. Now I'll just show you the implementation in C++. Okay, so I'll just keep it open here. I will move this guy to here. Okay, now I'll just keep it side by side here. Okay, so the C++ implementation is very much similar to what we have implemented in Rust. Okay, so yeah, I was initializing my answer as i64. Now the alternative in C++ is using long. Okay, now I'm initializing my answer as a long variable to 0. Okay, then I'm calculating the number of prices I have. Okay, then I'm iterating over all the elements. Okay, and here also I'm using the length, like up to which I can extend my window. Okay, now the while loop logic is pretty similar to my Rust implementation. Okay, now yeah, once I have extended the window, I know how many elements are there in the window. Now I'm just using their count, okay, to calculate how many more subarrays I can generate in that window itself. Okay, and yeah, finally I'm just doing I plus len minus 1. Okay, so yeah, then yeah, here I'm doing I plus len minus 1 because in Rust I was using a while loop. Okay, so here what is happening is, since I'm using a for loop, my I is automatically increasing by 1. Okay, by this incrementing statement. Okay, now if I do simple I plus len, so that means I'm already getting my next guy. Okay, at this iteration. Then once I do plus plus after that, okay, then I'll be basically doing I len plus 1. Okay, that means I'm skipping one guy. Okay, that's why I did a minus 1 here. Okay, so that this will be reset to the previous guy that I have covered in my window. Okay, then this plus plus will again reset it back to the next guy where I was like where I was in my while loop iteration. Okay, and then yeah, it will go normally. So yeah, that's the len minus 1 logic here. Okay, cool. Now this is the C++ implementation. Now if I simply submit, and voila, it got accepted. So here also the time complexity is the same. Okay, this the big O of number of prices we have been given, and yeah, because after that there are only constant time operations. Cool, then let's go with Golang implementation. Now this Golang implementation is also pretty similar to our C++ implementation. Okay, so here also I'm initializing one n, okay, which is the length of the prices. Then I have this answer variable. Now the alternative of long is this int 64. Okay, so I'm initializing my answer as a int 64 variable because I need to return that, right? Then yeah, simply I am iterating over all the for, like using the for loop, okay, to iterate over all the elements. Then yeah, you can see like all of the steps are pretty identical to C++. Okay, so the len is initialized to 1 because the current element is a part of the current window. Then I'm trying to extend my window, okay, using this for loop, because in Golang you do not have while loops. So yeah, I need to use for loop. So yeah, I'm using this for loop. Then in that window, once I'm extending, I'm just checking my next guy and the previous guy that I have in my window, their difference. If that difference is equal to 1, I'm keep on extending my window. And once I have stopped extending, then I'm also then I'm updating my answer to by this formula, which is this n times n plus 1. Okay, the number of subarrays I can get from that window. And finally, yeah, so here is the incrementing step, which is pretty similar to what we did in C++, because in Rust we were using while loop, so that time our increments were not auto incrementing. Okay, but here I have this incrementer. Okay, so because of that I will simply do len minus 1 here. Okay, otherwise I'll be skipping element. Cool, so this is the Golang implementation. Okay, now if I submit, and it also got accepted. Cool, so that's the video solution, and all three languages done. So the problem was pretty simple. Okay, it's just a standard sliding window problem. Okay, and yeah, that's the idea. So if you like the solution and the explanation, please do subscribe to the channel, and you can post any comment if you have any doubts. I'll be happy to answer that. Cool, so just stay tuned to watch more videos. Bye bye.